Yesterday we developed our understanding of the standard form of an equation of a line. Today we're going to take a look at the graph of that standard form of an equation. So over here on the left hand side in box 1 we have our standard form Ax plus By equals C with sliders for A, B, and C. Remember, those are just constants. Those are numbers in for those letters there. As we change the sliders for A, B, and C, you can see that the graph of this equation is always a line. Now, there are some interesting things that happen when you make A or B equal to 0. So let's put A here at 0, and you'll notice that this has now gone to a horizontal line. Likewise, if I change A and make it another number and put B here at 0, you'll see when B is 0, we now have a vertical line. Again, if I change some of A and C, I see that that line remains vertical. So there's some interesting properties here when A or B are equal to 0, but when A, B, and C are constants, then the graph of that standard form of the equation is simply a line. Let's take a look at a few examples for today. All right, in example 1, we're asked to graph the equation given in standard form negative 3x plus 2y is equal to 12. Now, it's actually quite easy to graph an equation that's given in standard form because all we need is 2 points, and we're going to get the 2 points of the x and the y-intercept. Now, remember, the x-intercept is found by plugging in 0 for y. So if I put 0 in for y, it essentially cancels out the y term. So I'm left with negative 3x is equal to 12. Divide both sides by negative 3. The x value is negative 4. So my x-intercept is negative 4. So I can go over on my x-axis to where negative 4 is and plot my first point. Now let's find our y-intercept. And remember, the y-intercept is where the x value is equal to 0. So in the equation, negative 3x plus 2y equals 12. If I'm to substitute 0 in for x, it essentially cancels out that x term, and I'm left with 2y equals 12, which means y must equal 6. So now I'm going to go up on my y-axis and plot my y-intercept, and it only takes 2 points to determine a straight line, so I'll connect those 2 points with my line, and there's the graph of the equation negative 3x plus 2y equals 12. All right, let's try another example. Here we have the standard form of the equation 0x plus 1y equals negative 2. Now, it looks like our value for a is equal to 0. Now, remember the interesting case when this happened, this is actually going to cancel out, and I'm going to be left with this y equals negative 2. And if you remember, it was actually a horizontal line, and this is going to be a horizontal line that passes through on the y-axis at negative 2. So here's negative 2 on my y-axis. Here's the horizontal line that passes through that point. It goes off from the left to the right. We actually have a slope of 0, and it's that horizontal line. Now, this is a graph of a line, so we can answer confidently yes here. And it's also the graph of a function. And this is simply the horizontal line. Now, remember the other case of when we had a number in front of the x, but we had a 0 in front of the y. If we had some number in here for c, let's say it's negative 2, remember this is what produces a vertical line, and that vertical line is the one that goes straight up and down, and that will have a slope that's undefined. All right, in our next example here, we're asked which, if any, of these equations represent the same line. Well, if they're the same line, they have to have the same slope, they have to have the same y-intercept. In other words, they actually have to be multiples of each other. So one thing you can do here by looking at each one of these equations is you can see that there's a common factor you can pull out of each one of those terms. If I factor out a 2, now think of factoring as like the reverse of the distributive property. So if I pull a 2 out of each one of these terms, I'm going to be left with x minus 2y equals 6. There's the equation of that line. Now, if I pull a 2 out of the equation for part B, I'm going to be left with x plus 2y equals negative 6. If I pull a 2 out of the equation for C, I'll be left with x plus 2y equals -8. And finally, in my last one here, I see all of these are multiples of 3, so I will pull out or factor out or reverse distributive property a 3, and I'll be left with x plus 2y equals -6. Now, which out of these four seem to be the same line? It's the ones that we have x plus 2y is equal to -6. So parts B and D will be equivalent lines. All right, one final example for today. We're asked to find the slope, the y-intercept, if any, and the x-intercept, if any. So what you'll notice, first of all, is that we're not written in standard form here. In order to do so, we need to move this -45 over to the other side of the equal sign. So I'll have 2x minus 9y is equal to 45. Now, remember how to go about finding our x and y intercepts. We simply let 0 equal the value for x in order to find our y-intercept. So when I do that, I'll have -9y equals 45. Divide both sides by -9. The y-intercept is -5. In order to find my x-intercept, I'm just going to do the opposite now. I'm going to put 0 in for y, and I'll have 2x is equal to 45. Divide both sides by 2, and x is equal to 45 halves. And that is my x-intercept. And finally, I want to find slope. So let's fill these values in while we're here. Now, in order to find slope, I'm going to go back to my original equation here. And I'm going to rewrite this in slope-intercept form. In other words, I need to solve for y. So let's go and solve for y by taking 2x minus 9y equals 45 and moving our 2x over. So we're left with -9y equals -2x plus 45. And finally, divide both sides by -9. And now I'm going to rewrite that so that I have y is equal to positive 2/9 x minus 45/9. And I am looking for the number that's in front of my x variable, that is my slope. So I say that the slope of this line is 2/9.